So that's one of the independent unit vectors that is the one that is the transmission axis, and then the other axis, the one that is the absorption axis, is sine alpha cosine alpha. And if you plot these, you'll see that they are indeed perpendicular. So one of them is for transmission and one of them is for absorption. So if we want to have a filter at an angle, we use this setup. Now, let's just do a simple situation, a simple phenomenon. Let's say we have a regular unfiltered light with all orientations, and we use a filter. The filter will be a filter for vertical light, 1, 0, and it will absorb horizontal light, 0, 1. And so emerging from that filter is going to be light that is vertical, 0, 1, 0. As I said, you can now measure it again and again. Whether you use a horizontal or a vertical filter, you will always find that this light is a pure state. It is vertically polarized, all of it, and you get the same answer consistently. Now, if we want to, say we want to put it into a filter that's at 30 degrees. Well, we just have to take our formula that we got for what the filter looks like. The cosine of 30 degrees is, let's see, let's work it out. If we have a 30-degree angle, it's 1, 2, square root of 3. So the cosine would be square root of 3 over 2. And then the sine would be minus 1/2. That's the first vector. And the second vector is the sine plus sine, and then also the cosine, square root of 3 over 2. So this is the 30-degree axis that's transmitting. This is the 30-degree rotated axis that is absorbing. And so now we want to figure out what happens to this vertically polarized light. Well, now we have to use our technique, vector technique, to find out the components of this 1, 0 vector that are parallel to each one of these two independent base vectors. So that means we want to go 1, 0, and then we want to find out what are the coefficients of that vector with respect to the transmission vector of the filter. And what is the coefficient with respect to the absorption vector of the filter, which is 1/2 square root of 3 over 2. Okay, so we want to figure out these two coefficients. In other words, this is the component of 1, 0 that is parallel to this vector. Well, we know how to find that. It's just the dot product. So the dot product of 1, 0 with this vector is going to be square root of 3 over 2. And the dot product of this v vector with the base vector is going to be 1/2. Do the x value times the x value plus the y value times the y value, so it's 1/2 plus 0. So we get square root of 3 over 2 and 1/2. So the transmitted probability, the probability the photon would be transmitted, is going to be square root of 3 over 2 squared, which is 3/4 or 75%. Well, that does make sense, we only rotated 30%, 30 degrees off of the vertically polarized orientation, so we're still transmitting most of the light, and here that 1/2 would be squared, and that would give us 1/4, or 70